Alrighty, welcome back, everybody. We are now in the How the Web Works section of pre-security, starting with DNS in detail. It says we're going to learn how DNS works and how it helps you access internet services.
Hey
We have a
everyone.
good video right here. It's about 15 minutes long. I would recommend just going through that. It will probably be helpful. But we're just going to go right through these tasks. It says it's supposed to be 45 minutes. Let's see if we can cut down on that just a little bit. But DNS is a pretty vital component of the internet, just how we do stuff nowadays, just the networking. So if you don't understand everything, maybe read through it again. Just get a good grasp of it. You're not going to be a DNS expert, but you should know what it does and a little bit of how it's doing it. All right. So DNS, the domain name system, provides a simple way for us to communicate with devices on the internet without remembering complex numbers. Much like how every house has a unique address for sending mail directly to it, every computer on the internet has its own unique address to communicate with it called an IP address. We learn about IP addresses. So an IPv4 would look like 104.26.10.229. So when you want to visit a website, though, it's kind of hard to remember that complicated set of numbers, and that's where DNS can help. So instead of remembering 104.26.10.229, you can remember TryHackMe instead. So the domain name system is providing a simpler way for us to digest that IP value. It's just translating it into something that, might be English or another language, like another, human speaking language. All right. So the first question is, what does DNS stand for? That's our domain name system. All right. Next, the domain hierarchy. So we have a good graphic here that's going over the root domain up in red. Top level domains are in the middle, and then we have second level domains. All right, so when we kind of put these together, you kind of see where we're going with this, okay? So you got a root up here, top level, which is your .edus, .com, .govs, .mils, tryhackme.com, google.com, your college.edu. Um, if you're part of any federal government things, it's .gov or .mil if you're in the DoD, stuff like that. All right. So a TLD, we're getting into some vocabulary here. A TLD is a top level domain, all right? And it is the most right hand part of the domain name. So, for example, the tryhackme.com, the top level domain is going to be the .com portion. And there are two types of top level domains. You have the generic top level domain, which you might see as GTLD, and a CCTLD, which is a country code top level domain. So historically, a generic top level domain was meant to tell the user the domain name's purpose. For example, .com would be for commercial purposes, .org an organization, .edu for education, .gov for gov, and a CCTLD, so that's that country code top level domain, was used for geographical purpose. For example, .ca for Canada, .co.uk for the United Kingdom, and so forth. But due to such demand, there's an influx of new gen- generic top level domains ranging from .online, .club, .website, .biz. If you've ever wanted to like register a website, and when it's giving you all those alternative ones, so like let's say if you want to get like hacking.com, someone probably already has that, but there's other top level domains that you can probably get for either a lesser cost or maybe someone hasn't actually done it. So here's a full list apparently of, oh god, of all the available top level domains. So like you could have something at .buzz or .casino, um, .gold. So you don't hear about these a lot, and .com is definitely probably the most popular top level domain. When we think of websites in the format, we all think of that www dot whatever .com, but there are other alternatives available. There really are. So .soccer, .softbank, .tattoo. Alrighty, so there's a lot of them. You don't need to memorize those, all right? There's not going to be a test on those. But knowing the difference between what is a top level domain versus the other ones, that's something you should know about. So let's go on to the second level domain. So if we are talking about tryhackme.com, the .com part is that top level domain that we just went over. TryHackMe is the second level domain. So now we're talking about these green ones. So in registering a domain name, the second level domain is limited to 63 characters, plus the top level domain can only use A through Z, 0 through 9, and hyphens. So you can't start or end with hyphens or have consecutive hyphens. So you can't do tack this and then tack or tack things like that. So not a lot to digest for the second level domains, just be able to identify what it is. Do remember that there is a character limit on it. So you cannot put a paragraph as your second level domain. It just doesn't work like that. Um, Next, let's go into the subdomain. So the subdomain sits on the left-hand side of the second level domain using a period to separate it. For example, and it's in the name admin.tryhackme.com, the admin part is part of the subdomain. So the subdomain name has the same creation restrictions as the second level domain. So that's at 63 characters, only use A through Z, 0 through 9, and hyphens can't be at the beginning or end or consecutive. But you can use multiple subdomains to split with periods to create longer names, such as jupiter.servers.tryhackme.com. So you can start adding on more subdomains, but the length must be kept to 253 characters or less. So that's your maximum amount that you can put for all your subdomains and all that fun stuff all together. All right. So there's no limit to the number of subdomains that you can create for your domain name, so you can keep doing more and more subdomains. Just it can't get past that limit. So we're going to go ahead and say we're going to answer these questions. So we have 4 questions. So what is the maximum length of a subdomain? So I think we said that a couple times. And it's going to be 63. So it's right up here. Which of the following characters cannot be used in a subdomain? So between 3, B, an underscore here, or the hyphen. All right. So you cannot use the underscore. And then what's the maximum length of a domain name? So that is going to be the total of all of them with all the subdomains. That's a 253 character limit. And what type of top level domain is .co.uk? So this is asking between, is it one of the generic top level or is it a country code top level domain? All right. And because this one's associated with the UK, the United Kingdom, we are going to do CCTLD. Boom. Alrighty. Moving right through this. Onto DNS record types. So this is a fun one. Honestly, been doing my certificate stuff. It's part of it, but I often have to resort back to Google if I'm dealing with this at work, just so I know that I'm on the right track with what I'm supposed to be doing. All right. So, DNS record types. DNS isn't just for websites, though, and multiple types of DNS records exist. We'll go over some of the most common ones you're likely to come across. So, you have your A record. These records resolve to IPv4 addresses, so that's our good old 4 octets, the 104.26.10.229. We have our AAAA or quadruple A records over here. And these are all to IPv6 addresses. So that's where they start looking a little bit funky with alpha and numerics in them. Go back a couple lessons back when we were talking about IP addresses if you want to really know about the difference between the two. We have a CNAME record. So these records resolve to another domain name. For example, TryHackMe's online shop has a subdomain name of store.tryhackme.com, which returns a CNAME value of shops.spotify.com. Another DNS request would then be made to shops.spotify.com to work out the IP address. So it's resolving to another domain name. In MX record, these records resolve to the address of the servers that handle the email for the domain you are querying. For example, an MX record response for TryHackMe would look something like alt1.aspmx. I think that's an l.google.com. All right, so these records also come with a priority flag. This tells the client in which order to try the servers. So this is perfect for if the main server goes down and an email needs to be sent to a backup server. So it's lets you know where the email needs to be going. Then you have a TXT record. So these are free text fields where any text-based data can be stored. So TXT records have multiple uses, but some common ones can be to list servers that have the authority to send an email on behalf of the domain. So this can help in the battle against spam and spoofed email. They can also be used to verify ownership of the domain when signing up for third-party services. So if you have a third-party service, sometimes in order to prove that the domain is actually yours, they'll say, hey, put this flag into your TXT record, all right? And that being what it is, it's a way to prove proper ownership, all right? So what type of record, we're going into the questions now, what type of record would be used to advise where to send mail? So that's going to be our MX record. And what type of record handles IPv6 addresses? So that's going to be our AAAA record. Please, if somebody knows what the actual distinction, what to call that, whether it's quad A, whatever, let me know. All right. Next, making a request. So what happens when you make a DNS request? All right. So when you request a domain name, your computer first checks its local cache to see if you previously looked up an address recently. If not, it sends a request to your recursive DNS server. All right. So recursive DNS server. We're going to go ahead and look at this. So right now, it's checking itself. If it doesn't, then it says, okay, I'm going to reach out to the recursive DNS server. A recursive DNS server is usually provided by your internet service provider, your ISP, but you can also choose your own. This server also has a local cache of recently looked up domain names. If a result is found locally, this is sent back to your computer and your request ends here. This is common for popular and heavily requested services like Google, Facebook, Twitter, things like that. So if your request cannot be found locally, though, the journey begins to find the correct answers starting with the internet's root DNS servers. So if your computer doesn't already have an entry to say that this IP address resolves to this website, this domain, it will then reach out to your ISP's recursive DNS server. All right. And if they don't have it, then we're going to start going out to the internet looking at the root DNS servers. So the root servers act as the DNS backbone of the internet. Their job is to redirect you to the correct top level domain server depending on your requests. For example, if you request tryhackme.com, the root server will recognize the top level domain of .com and refer you to the correct TLD, the correct top level domain server that deals with .com addresses. The top level domain server holds records for where to find the authoritative server to answer the DNS request. The authoritative server is also known as the name server for the domain. For example, the name server for TryHackMe is kip.ns.cloudflare.com and uma.ns.cloudflare.com. You often find multiple name servers for domain names that act as a backup in case one goes down. All right. So not all the eggs are in one basket. There's there's multiple of these, and it's just whatever is the most efficient way to actually get your DNS requests resolved. Right. On to part 5, an authoritative DNS server is a server that is responsible for storing the DNS records for a particular domain name and where any updates to your domain name DNS records would be made. Depending on the record type, the DNS record is then sent back to the recursive DNS server where a local copy will be cached for future requests and then relayed back to the original client that made the request. DNS records all come with a TTL value, that's the time to live value, and this value is represented in seconds. Now the response should be saved for locally until you have to look it up again. Caching saves on what it saves on having to make a DNS request every time you communicate with the server. So instead for every time you're trying to resolve facebook.com or something, you are constantly making requests over and over and over. They don't have to do that because it's cached, all right? So let's go and answer some of these questions. All right, so what field specifies how long a DNS should be cached for? And that's going to be that time to live value. All right, so that's the TTL. Now, what type of DNS server is usually provided by your ISP? So if we look over here, We went over recursive DNS servers, root DNS servers, and authoritative DNS servers. All right. The recursive was the one from your ISP. The root DNS server is out on the internet. And then the authoritative one is one that's responsible for storing DNS records for a particular domain. Alrighty. So knowing that, we want the recursive one. All right. And what type of server holds all the records for a domain? That's going to be that authoritative. Authoritative. There we go. Sorry if I was saying that wrong earlier. Authoritative. There we go. Cool. So moving on now, we have our practical. So let's go ahead and start this up. So using the website on the right, we can build requests to make DNS queries and view the results. The website will also show you the command you need to run on your own computer if you wish to make the request yourself. So while we're doing this, anytime in TryHackMe that there's anything that's going with commands, I like to bring up a notepad little area and make a little cheat sheet of whatever we went over in the area so that I have my own little repository of tools that later I can go through, because I'll be honest, these requests right here, if you ask me 2 months from now, how exactly do I look that up? I'm not going to remember each and every piece, but at least I know where to look. So I like to create little tools along the way. So if we look up, so looks like our command is going to be ns lookup, then the website. Boom. So we'll start with that. So our first question is, what is the CNAME of shop.spotify.thm? So if we go over here, we have different DNS types. We want the CNAME, and we are going to put shop.website.thm. All right, so I'm going to say for CNAME, and do ns lookup type equals CNAME, then the subdomain. So I'm just going straight up with these examples. I can parse that out later for what exactly I was looking for here. And then we send a DNS request, and it says the non-authoritative answer is shop.website.thm. The canonical is shops.myspotify.com. So we're going to do shops.myshopify.com. Submit. Cool. Sweet. Next, what is the value of the txt record of the website.thm? So we're going to go back to our notes here. We're going to say for txt and do ns lookup type equals txt. And you notice there's already going to be a format here. So it's going to be ns lookup type and then whatever the type is. All right. So we can do send DNS requests, non-authoritative answer for this flag right here. So THM, then the flag value. So we're just going to go ahead, copy, and paste that. Boom. Sweet. Got it. Next up, we are going to go over MS records. All right, for an MS request. So let me go ahead and put for MX, and we're going to do that. Whoops. Boom. Let's just go ahead and look up copy for boom. Then we're just going to say website.thm and send that DNS request. Oh, if it wants to work with me. Let's see, did I mess this up? What is the numerical priority value? There we go. And it just didn't click, right? All right. So let's go ahead and do this. So looks like our website.thm mail exchanger equals 30. And then it gives us that mail right there. So we'll go ahead and put 30. And finally, we're going to look at the A record of the website. And that is going to give us an address of 10.10.10.10. Because if you remember, A records are for the IPv4 address, right? So let me just go ahead and do this. Boom. A. Sweet. And if we think about it, you probably could get away also with doing it maybe with another one. So let me go ahead and do a command prompt. Alrighty. So if we do ns lookup type equals, maybe this will work, maybe it won't. If I could spell, that would be great. Invalid option. So we can't do that. But hey, let's see. We did get this address right here. So non-authoritative answer for Google, and it gives us an IPv6 address. Because remember, the types A would be an IPv4. So let me see if we can go ahead and get that IPv4 for Google. All right, here we go. And it's that 142, boom. So talking about DNS, if I go and put in this address right now, so if I do this 142.250.72.174, so let me go ahead and let's see. Nope, can't copy it. So give me one moment. 142.250.72.174. Alrighty. So let's go and, oh, my little screen share thing's up top right there. So we'll just go right here. And y'all probably didn't see that, just where that was at. All right. So we have this IP address. All right. We're going to go ahead and hit it, and it resolves to Google. That's all that this was about, was being able to resolve IP addresses in a digestible way through domain name. All right. Because nobody wants to remember, hey, I need, if someone says, hey, go look this up on Google, and they say, all right, well, go to 142.250.72.174, or even worse, that IPv6 address. That just doesn't, it, I know I'm not that wise to be able to get all that together, but if you can, that's great. But the domain name service is there to help us out. So with that, I'm going to go ahead and hit submit. Congratulations, we have completed DNS in detail, the first room of this next area of the pre-security. So thank you all for watching. We're going to keep on going to the next one. All right, thank you. Bye-bye.